matrices is what we're going to do today. If I can actually get this to AirPlay, it'd be really good. Okay. All right, here we go. Section 4.7, communication matrices. Okay, so matrices are beneficial for organizing information. That's the main thing that we use them for. Okay. All right, so we can use them to organize information in a diagram. We can use them to organize systems of equations, as you guys have seen in the past. So let's imagine we've got points A, B, C, and D, and it represents 4 ships out at sea within communication range, okay? An arrow indicates the direction of radio transmission, okay? So for example, if you have an arrow that emanates from one ship to another ship, that means that ship can directly communicate that other ship. Like, so for example, if you look at A to B, there's an arrow going from A to B. That means A can send a signal or a message to B, okay? So while ship B can send a message to A, ship B cannot send a message to D. You guys see that there's no arrow going from B to D, okay? Now, ship D can indirectly communicate with ship A, but it has to use ship C as a relay. So like there's no arrow going from D to A, but D could first send a message to C, and then C can send a message to A, okay? All right, so that's what's going on, okay? So the communication matrix M can be used to keep track of what ships can communicate with each other. A 1 indicates that you can have direct communication between those 2 ships. So it means there's an arrow that goes from one to another. A 0 indicates that direct communication is not possible, okay? The way our matrices are going to read, on the left side is going to be from which ship we're working with, so A, B, C, D. And then along the top, our columns are going to be to the ship, okay? And then notice diagonal elements are all 0. Why are the diagonal elements 0?
You can't communicate with yourself.
Yeah, so it's like, why would we have an interest in communicating to ourselves, right? There's no arrow shown that does that, okay? Now, we will talk about that here in a second, though. So that's what M looks like. That's our communication matrix, okay? If I square that matrix, that has other information that relates to it as well, too. Why is this all messed up? Okay, first of all, these should all be in matrices. I'm not sure why they aren't, but these should all be like within. Are they on yours?
Yeah.
I don't know what happened to my file. All right. Well, hopefully it doesn't mess anything up. I'm just going to ignore that. All right, so either way, while M gives direct communication links between ships, M squared, so if you square that initial matrice, gives indirect 2-step paths that use one ship as a relay. Okay, so that was like the example of like B going to D. B can't directly go to D, but B can go to C, and then C can go to B. Okay? All right, so M squared shows the number of 2-step paths that are possible. Okay? So like, for example, if I look at that blue circle, there's that 1 there. After you square M, what that means is there's one 2-step path to get from D to B, okay? D has to go to C, and then it would go to B. That would be that 1 indicator, okay? All right, now, if you add together M and M squared, what that gives you is the number of paths that take 1 or 2 steps, okay? So if you add those 2 matrices together, it's the number of ships that can directly communicate plus the number of ships that can communicate with a relay. Okay, so that's what that value is, okay? So like that red 2 that's circled there shows that there's 2 paths that go from C, because this would be from C to, is this messed up on mine and not on yours?
No, it's lost.
Oh, it is. See, it's on yours, it's shifted. It should be like that. Man, that's super unfortunate. Hold on. Let me erase. That's which element is circled on yours, right? In that matrix. I'm not sure why, again, easy boys. I'm not sure why it erased it on mine. That's pretty inconvenient, but either way. Okay, so either way, this shows the ships that can communicate with each other and how many paths that can take. All right? So, let's do an example, okay? So let's say we have this matrix M and it models communications between computers, W, X, Y, and Z. Okay. All right. Let's draw a diagram that illustrates what's going on in that matrix. Okay? So we've got a diagram, we've got a bunch of points labeled, so we want to draw in those points which ones can communicate with each other. Okay? All right, so let's start with W. And let's draw arrows from W to the other computers. Okay? So again, this is from along the rows and then to along the columns. Okay? So I can go from W to what other computers?
X and Y and Z.
X, Y, and Z. So I'm going to draw an arrow from W to Z, an arrow from W to X, and then an arrow from W to Y. All right? Cool. Now let's do from X. I can draw an arrow from X to where? W and Y. So here, and then from X to Y. All right? Now what about Y? I can draw an arrow from Y to where? And that's it, right? There's only one entry there. And then what about Z? Z can go to where? And then also to Y. All right, cool. So there's our diagram. Okay? All right, now we want to figure out the computers that can send data along the greatest number of routes with one relay. Okay, so what that's asking me to do is it's asking me to do M squared. So what I need to do is I need to multiply that matrix by itself. You want the good news or bad news first? The bad news is it's a 4 by 4. That kind of sucks. The good news is there's a ton of zeros. Colin already quit. But it shouldn't be bad. Okay? All right, so we do rows by columns, right? All right, so the first one, I'm going to do 0 by 0. So I'm going to do rows by columns.
No, Colin, you're wrong.
What does M squared tell us? It's the amount of computers that can communicate with each other with one relay. Okay? So M just tells us the computers that can communicate with each other directly. M squared is how many computers can communicate with each other with a relay, with one relay. Okay? All right, so along my column, what am I going to get when I multiply these? What am I going to end up with? What's my first value? 0 plus 1 plus 1 plus 1 giving me 3, right? I'm going to try to just do them all in our head, okay? All right, let's do our next entry here. So let's do, I don't know, right here, I guess. All right, so we're going to do top row, second column. So that would be 0 plus 0 plus 0 plus 0. I'm getting a 0 there. No, what did I mess up? What do I get there? No, I think I have it right. Right? So it should be 0. You do,
That's right.
because it's along the first row, Andy, and then second column. Okay. All right. Amog, what's up? Because I'm trying to get M squared. I'm trying to get this right there. That'll tell you the amount of computers that can communicate with each other with a one-step relay.
How does multiply going to give you a one-step relay?
Because it tells you, so if you multiply the matrix where you've got direct communication, if you multiply that by itself, the square gives you the amount that they can, when you do the matrix multiplication, you'll see once we go through these, it's all the elements that can multiply by each other. So it tells you which ones can communicate when you add them all together. All right, we lost a lot of time with that. That's okay. All right, so what's our next element going to be? 2? What's our last one?
0.
Great. Okay, cool. All right, so that means there's 5 for this one, okay? Because I can add all those together, and that would tell me that W can communicate with 5 amounts of communication if you add all those together. All right, so let's do the next one. So now we got to do the next row by our first column. What's that going to give us? 0, I think, right? No, it should be 1. Yeah, it's 1. Yeah, it should be 1. All right, and then let's do second column. Also 1. What about third column? Yep. Last column? Is it 1?
Yeah.
It is. All right, so then that's 4. All right, what about the next one? 0, 1, 1, 1.
One.
There's 3?
I think so.
Okay. What about my last one?
One.
1,
One.
Yes, that's correct.
2.
2.
1.
So then that,
5.
I don't think that one's...
I'm right.
These are 1s, right?
It's one.
I think those are all 1s.
Shouldn't it be a 2? Oh, wait, no, because there's a 0 there.
Yeah, yeah. All right, so which computer can communicate with, can send data along the greatest number of routes? It'd be W, good. Yeah. So computer W. Okay. All right, and then if you find the matrix that represents, so if you do m plus m squared, that's the amount of computers that can send data along the greatest amount of routes using one relay or less. So if I add together what I got for m squared, which is here, to m, then that'll tell me how many computers can send data along the most amount of routes with one relay or less. Okay? What's that?
That's silly goofy.
Maybe. Try it out. See if it works. Yeah. All right. Either way, your homework for 4-7 is at the end of this, but I want you guys to focus on 4-4, 4-6 tomorrow. I'll lecture a little more on this tomorrow, and then you guys will do homework for 4-7 tomorrow.
Do we have a quiz tomorrow?
Yes. 4-4, 4-6. This is not on it.
Not.
This is not on it.
If you read the board,
I didn't.
Battleship.
he puts them on the board.
This is kind of like Battleship, right? Kind of. Not really. A little bit, though. There's ships involved. Matrix what?
No.
There's
I
nothing
understand
better- there's nothing
communication.
good than
I understand the point of
Oh, wait. I thought I was done with you guys. I still have 10 minutes. Oh, baby. Let's keep going. Never mind. I thought it was 1:40. All right. Now let's keep going. All right. Cool. So then we just found what m squared was. So computer W can send data along the most amount of routes. Sorry. What's that word you guys use? Gaslight? Is that a word? I just gaslit you into thinking the class was done, but it's not. It is. We're still going. Okay, cool. All right, so let's do m plus m squared. Should we be smart about this? No, never mind.
Yes.
You can talk about like that timer or something?
All right, so I want to add together m plus m squared. Was it 3, 1, 3, 1?
Yep.
Yeah.
2, 1, 2, 1. It's the second row. 1, 1, 1, 1.
All the ones. 2, 1, 2, 1.
Can we be done with class now?
No. No, we can't. All right. So find the matrix that represents the number of ways messages can be sent from one to another. So there we go. All right. Let's write a communication matrix for the last one. And then we'll be done.
If it was m cubed, would that be the number of 3 step pass?
2 steps, 2 relays.
If it was m cubed.
Mm-hmm. 2 relays. M squared is 1 relay. So m cubed
Oh.
would be 2 relays.
That's still 3 step pass.
Yeah. I'm pretty sure.
M to the fourth.
3 relays.
Now we're cooking. All right, well, hey, here's the good news. There's just 3 elements. 3 by 3. That's the good news. All right, so from A to A, 0. From A to B. Can I do that? 1. Okay, from A to C? 0. Good. All right, from B to A. From B to B. Nice. From B to C. Nice. All right, from C to A. C to B. C to C. Hey, you guys are pretty good at this. You're welcome. All right, cool. So your homework is this. Once you guys take your quiz tomorrow, then you can just do this homework, and that's what class will look like. Okay?
So the homework for tomorrow is this?
Yep. Don't worry about doing this tonight. Study for 4446. 444546.
We have a lot of time for quiz tomorrow.
Can we have the whole class?
Do you want the whole class, Caitlin?
Yeah.
Caitlin wants the whole class. So we'll do the whole class to take the quiz. Just open-ended as much time as you want. Sound good? There you go. Hooray. Is there a 4-8?
Yeah.
There is a 4-8.
So are we,
Huh?
how many does it go to?
I think 4-9.
So we're gonna have a 7. Are we gonna have another quiz?
Yeah, probably. Yeah.
What time are we at?
4 minutes.